Now in this session we will cover problems related to resonant circuit as well as DC to DC converter, that means chopper. Now dear see, we have already discussed many problems related to phase control rectifier, power semiconductor devices and all topics around of circuit theory also. So if you have any doubt related to all those topics, you can ask in today class, and day after tomorrow our lecture will be last of this series or last lecture of this series. So if you have any query or doubt, please ask to me. Okay. Now dear, we are going to discuss our first example, and in this example we have to calculate the average current. Okay, we have to calculate the average voltage, wait a minute, average voltage and load current through this. Okay, we have to calculate average voltage across the load and average current through the diode is our main task. Okay, now tell me everyone the name of this converter. Okay, DC to DC converter, how many type? DC to DC, first is step down chopper. For a step down chopper we have V0 equals to alpha into Vs in general if current is continuous or for pure resistive load, where alpha is duty cycle. And case 2 beta ji, step up chopper, and in step up chopper we have formula for continuous inductor current Vs by 1 minus alpha. Okay, where alpha is again duty cycle. And last one, which is similar to auto transformer in AC case. Okay, so last one is BBC, buck boost converter, and buck boost converter can provide both type result, like similar to step up chopper and step down chopper. So for this we have formula alpha into Vs by 1 minus alpha. Again dear, this formula is valid when IL, inductor current, is continuous and the volt second criteria must be satisfied in all cases. Otherwise we are not supposed to use this formula. Okay, now see everyone, please mind it also, but when we have any converter in such fashion, okay, something diode is present and inductor is present load side. Okay, so this is the load side. If inductor is present load side, then our converter will be step down. Similarly, if inductor is present source side, okay, inductor is present source side, then it will be step up chopper. Okay, it will be step up chopper. Now sometimes my dear friend, we can connect one capacitor across the load also to control the ripples of output voltage. So if inductor present load side, it will be step down. If inductor present with series with supply, it will be step up. And if we have a circuit, dear friend, if we have a circuit in such a fashion, okay, something like this, that means inductor is present in first case with supply and in second case with load, then it is called buck boost converter. Okay, then it is called buck boost converter. So this is a buck boost, step down and step up. Now dear, tell me the name of this converter, the name of this chopper circuit, everyone. Dear, the name of this chopper circuit will be step up. Why it will be step up? Because dear, in step up converter, we have inductor in series with supply. Okay, this is our supply. And please mind it everyone, in chopper circuit or in any other converter, P naught, that means load power, will always equal to source power. Doesn't matter inductor current is continuous or discontinuous. Please mind it. Doesn't matter inductor current is continuous or discontinuous. Okay. Why it doesn't matter? Because dear, whatever power supply will deliver, same amount of power load can consume. See, if our converter is ideal or the devices, for example, SCR, MOSFET, IGBT, whatever, and diode are ideal, so no loss in the switching or conduction. We are assuming these losses are zero. My dear friend, if we assume switching losses and conduction losses of the power electronic devices are zero, then obviously whatever power supply will deliver will reach to load. In that case, both terms will be equal. But if electronic devices are introducing power losses in the switching and conduction period, dear friend, in that case, we should write PS is equal to P naught plus P loss in switches. Okay, P loss in switches. But generally, okay, it is not necessary, but in general it happens, they provide ideal devices. They provide ideal devices. Okay. Here, my dear friend, in the example, nothing is written about the devices. Okay. In the circuit shown in figures which operated at duty cycle 0.5, a large capacitor is connected across the load. The inductor current is assumed to be continuous. Okay. So here one information is given, the IL is continuous. But here I would like to suggest you one most important thing. I don't know how to analyze whether in the given converter whether inductor current is continuous or not. Dear student, always follow Bolt-Second criteria. I repeat, always follow Bolt-Second criteria of inductor in a positive region, that means when inductor is absorbing power, and in negative region when inductor is delivering power. If we are capable to satisfy this criteria and the inductor voltage waveform VL is continuous, please mind it here, is continuous. If the inductor current is continuous, if the inductor voltage is continuous, please mind it, inductor current will also be continuous. So this is the basic thing or very important thing regarding whether inductor current is continuous or discontinuous. Okay. According to my knowledge or experience, more than 99%, or we can say almost 100%. Okay. Students are not aware in the chopper circuit about the phenomena of continuous current and discontinuous current. GATE 2018 asked one question related to this, and many of even student included all members. Okay, I don't want to say anything. Apply some different formula to solve that type of circuit. I say, my dear friend, we don't require anything like mug-up approach or proved approach. Just apply this Bolt-Second criteria. Okay, just apply this Bolt-Second criteria. We can determine each and everything related to any converter, not converter like chopper. For phase control rectifier, uncontrolled rectifier, inverter, each and everything. Okay. Please mind it, generally in inverter, we don't have discontinuous mode. I repeat, generally in inverter, we don't have discontinuous mode. But in chopper circuit and in phase control rectifier circuit, we may have. Sometimes this discontinuous mode is useful also. It's useful also. When we want to run our motor for some time and don't want to operate our motor for a certain time, then this discontinuous mode is somewhat useful. But generally we don't want to use discontinuous mode, so more than 95% question or 90% question ask from continuous conduction. Okay, so here is written, my dear friend, the inductor current is assumed to be continuous. That means the value of L is capable to operate this system in any time interval of capital T, where T is time period of this time period of one cycle. Now dear, the frequency of this electronic device is very high. I repeat, frequency of electronic devices very high. So time period generally in terms of milli or microsecond. You know very well, my dear friend, any inductor or capacitor can operate considerable load with a constant rate of voltage and current for very low time interval. For very low time interval. That's why here inductor will work as a source when you require this output voltage greater than input voltage. So the moment at which this switch is on, this inductor will get charged, and but when this switch is off, this inductor will change its own polarity and will work as a source, so power will flow in such fashion. In this case, second case, that means when chopper is off or main device is off, automatically or naturally this diode is on because of changing the polarity of this inductor voltage. This supply and inductor both will work as a source for this load. So please mind it, my dear friend, that type of circuit configuration are called step up chopper. Step up chopper. Okay. Now for step up chopper, my dear friend, mind it. Okay. For step up chopper, I want to write here, beta. For step up chopper, when, please mind it, when IL, which is also equal to source current IS, continuous. Please mind it, V0 is equal to Vs by 1 minus alpha. Now see dear, he is saying IL is continuous, supply voltage is 20, asking average output voltage. So what will be the average output voltage? Average output voltage is nothing but 20 by 1 minus 0.5, because duty cycle is given 0.5. So how much this voltage? 40 volt. Okay. So V0 average will be 40 volt is first answer. Now dear, see, he is asking average voltage, then average current through diode. Dear, see, average current through diode. Dear friend, the average current of this capacitor is 0. Please mind it. Why average current of capacitor is 0? Because the charging and discharging, again, current second criteria will satisfy for this capacitor. So we can write this I0 average will be equal to ID average, because this IC average is 0. Because this IC average is 0. Otherwise, suppose IC average is not 0, beta, then we cannot write this I0 average equal to ID average. Please mind it. So generally, our converter, that means step up chopper, will satisfy not only step up, step down, buck boost, anyone. Okay. So here I am going to write, my dear friend, the capacitor current IC average will be 0. Due to this reason, ID average will be equal to I naught average. And there, with the help of transformer action, we can write V naught by Vs is equal to Is by I naught is equal to 1 minus alpha. Okay, like similar to for transformer we write now V2 by V1 is equal to N2 by N1 is equal to I1 by I2. Okay, same equation we are following here because here input power equal to output power. Okay, approximate when we are not considering any loss in the converter. Dear, this formula is very useful for the given converter. Again minded, this formula or any other formula, whatever we have derived in standard way are possible only when IL current is continuous. Only when IL current is continuous. So beta ji, I naught average we don't know or we have to calculate. What about IS? IS is given how much 4 ampere? In converter, when any quantity is provided by someone, that quantity should be DC. If that person is not mentioning anything about that quantity, so first preference would be DC. So this 4 ampere current is the DC current. My dear friend, we can write 4 by I naught is equal to 1 minus 0.5. Okay, 1 minus 0.5. So 0.5 into 4 is how much? 2 ampere. And as I told you, I naught is also equal to ID average. So this current also equal to ID average. It's a very important for this converter. Now dear, as I told you, in any converter, the supply power is equal to load power. Okay, supply power is equal to load power. So dear, if we are writing PS is equal to P naught, if we are writing PS is equal to P naught, what about supply power? Okay, supply power. What is the supply voltage, dear everyone? Supply voltage is 20 volt. Okay, just wait a moment. Supply voltage is 20 volt. Just see in the figure. And supply current is 4 ampere. So, I'm going to write here PS is equal to 20 into 4 is how much? 80 watt. If our converter is ideal, my dear friend, then load power should be equal to 80. Now see dear, this is step up chopper. In step up chopper, output voltage will be equal to output voltage is greater than input voltage and output current less than output current greater than input current. So it is a step up chopper. Supply voltage is 10. So output voltage should be greater than 10. That means option A and B are wrong. Now beta, in step up, current will be step down. So output current will be lower than input current 4 ampere. Will be lower than input current 4 ampere. Okay. So here 40 volt and 20 volt will be our final answer. Now what will be the output power? Output power is nothing but 40 into 20 is equal to 80 watt. So dear, efficiency of this converter is, yeah, Asu, hi dear, P naught by PS. It means almost 100%. It means almost 100%. It is clear to all? Now please everyone, read this question carefully and tell me correct option, correct choice for this question. Yes, everyone. Okay, just read this question carefully and tell me the correct answer. A buck boost DC to DC converter, you can reply, my dear friend. A buck boost DC to DC converter, as shown in figure below, is used to convert 24 volt battery to 36 volt DC. Okay, so 24, 36. And voltage feed to load is 72 watt. 72 watt. It is operated at 20 kilohertz with an inductor of 2 millihenry and output capacitor voltage. Okay, it is not 1000 microfarad, it is 10 microfarad. Okay, 10 microfarad. Please mind it. It is 10 microfarad. All devices are considered to be ideal. The peak voltage across the solid state device will be in volts. Yes, everyone, dear, tell me. Now tell me, everyone, a type of this converter. Type of this converter is, I'm giving you option, beta. Step down chopper, step up chopper, or buck boost converter. Step up, step down, or buck boost. See, as I told you, in step down, inductance is present load side. In step up, inductance is present source side. And in buck boost, inductance is present in between supply as well as load. Okay. So this converter beta will be buck boost converter. Already it is mentioned in our problem. Okay. Already mentioned. Now dear, in the same problem, just tell me what will be the maximum voltage across this switch. You have these options. Yes, everyone. Read this example carefully and tell me. Yeah, how much here? 36 volt, this voltage, and load power is 72 watt. You have to just give me tentative idea, or you can just tick your option A, B, C, D, whatever. Okay, dear. Now see, beta ji. First, tell me this 36 volt is constant or variable. Please tell me, everyone. This 36 volt is constant or variable. Yes, everyone. Or you can also tell me this 36 volt is pure DC voltage, pure DC voltage, or any other thing. That means here, beta, let us assume this V0. Can we draw this V0 waveform something like this, and writing here 36 volt will be right or not? Yes, everyone, will be right or not if I write 36 volt? Okay, for all time, suppose. Dear, see, 36 volt is the average voltage. As I told you, in the converter, whatever parameters are given, if they are not mentioning their units, you should consider those values only in DC terms. So this 36 volt is actually average output voltage. Please mind it, everyone. V0 average is 36 volt. The V0 waveform will not look like something, beta. The V0 waveform will look like, wait a minute, the V0 waveform will look like something like, okay, here there will be some variation in voltage with respect to time, dear. The variation with respect to time, we can write here V naught min, this is V naught max, or you can also write VC max, VC min, something like this. Okay, VC min. And beta ji, here we have one average voltage also. Average voltage also. And the value of this voltage is V naught is equal to alpha into Vs by 1 minus alpha. And this value, this black color value is given 36 voltage. Actually, this is the thing. Okay. Now dear, if output voltage is 36 volt and supply voltage is 24 volt, then what can be the maximum voltage across this switch? Dear, due to this capacitor, a ripple will control but will not be zero. Doesn't matter what is the value of this capacitance, 1000 microfarad or 10 microfarad. Whenever the value of this C beta decreases, the ripple of Vc increases. The ripple of Vc increases. If the value of C increases, the ripple of del Vc decreases. If the value of C decreases, the ripple of output voltage increases. So what is the main purpose of this capacitor? The main purpose of this capacitor is nothing but to control the ripples of output voltage. And dear, please mind it, the ripple current or extra amount of current can also flow through this capacitor. And in some duration, when this diode is off, this switch is on, please mind it, this capacitor can work as a source also. So we have many advantages of this capacitor, but the main purpose to connect a capacitor across the load is nothing but to reduce the ripple of output voltage. In GATE 2016 or 17, whatever, they asked that question with C is equal to 1000 microfarad. Many of the members, betaji, didn't solve this problem correctly. Okay, so just keep in mind, due to this value of capacitance, ripple of this will vary. What is the ripple formula? We don't require here because options are like not in absolute way. Okay, I will tell why. Dear, the moment at which this switch is open, off, it will block voltage, and when this switch is on, it will not block any voltage. So say here some voltage V1, say here some voltage V2. Okay, what is the value of beta V2? DC wise minus 36 volt, and from here 24 volt. But this minus 36 beta has some ripple also. Okay, plus minus del Vc, 5 volt, 10 volt, 1 volt, 0.5 volt will depend actually upon the value of C. But definitely this term will not be zero. So if we add minus this and minus this, then this value will be greater than magnitude wise 36. And if we add here by potential difference rule, like VSW will be V1 minus V2. So V2 is already negative, so negative, negative, positive. So this voltage 24 plus 36 is 60, and this voltage del Vc will also add. Okay, actually del Vc by 2 will add. So del Vc by 2 will also add. It means our switch voltage will be more than 60 volt. What will be the correct answer? You can learn in my power tonic classes I'm taking on Unacademy. It will start by 22nd, okay, of this month, and the timing of this class is 11 AM to 1 PM. Okay, in this particular time interval on Unacademy platform, beta ji, 11 AM to 1 PM, it is 2 hours class regularly. Okay, and we will complete this power tonic syllabus around 100 hours plus. Okay, 100 hours plus. So you can join Unacademy for the better and the best concept of the power electronics. And it's my promise that whatever I'm giving to you in this subject, okay, in general, you cannot take that much of information from any other, like okay. So now dear, our next example is this one. Okay, yes sir, thank you Abhishek. Okay, so now D, the chopper shown in figure operates at a frequency of 100 Hz with an on time of 4 millisecond. The average value of load current is 20 ampere with the peak to peak ripple of 4 ampere. Neglect the average value of diode current. Sorry, calculate the average value. What? Neglect. Okay, neglect losses. The average value of diode current is. Yes, everyone, please tell. It is a very simple example, dear friend. You can tell very easily. Okay. Yes. So tell me first the name of this converter. Step down, step up, or BBC? Which one? Yes. So dear friend, it is nothing but see, supply side is no inductor and inductor is not common in between source and load. So it is a step down converter. Yeah, Abhishek, you are absolutely right, beta. So it is a step down converter. Now dear, my question is, with on time something, the average value of load current 20 ampere and the peak 4 ampere. Okay, the average current of diode. Before that, I want to know, beta, first tell me whether this current IL is continuous, is continuous or discontinuous. If you are capable to tell this thing, whether this current IL is continuous or discontinuous, you can follow all formula related to step down chopper. For example, alpha into Vs is average output. Ripple is beta ji, alpha into Vs into 1 minus alpha into T divided by L. And the condition for just continuous and discontinuous mode, alpha for just continuous mode will be 1 minus 2L by RT. So this formula, basically these two you can use if this IL is continuous. If not continuous, you are not supposed to use these two formula. Okay. So yeah, somebody is saying that current beta IL will be continuous. Okay, IL will be continuous. Now see my dear friend, how can be this IL continuous? For that we have to see few points. First see dear, the chopper operated something frequency is 100 Hz. So what will be the time period? 1 by this 100 is equal to, I think 20 and 10. See beta, 10 millisecond is right. My dear friend, this 100 Hz frequency is a very small frequency. Please mind it. We never design any power electronic devices at 100 Hz of switching frequency. It is very dangerous for the converter because switching loss will be high as well as switching time interval. You can say transient time will be very large. To reduce this transient time, we should select high frequency to design our power electronics converter. Okay, dear, please mind it. This frequency 100 Hz is not kind of high frequency. It's a very low frequency. And please mind it, my dear friend, I'm not sure whether do you have this much of concept or not. But this formula, whatever written here, is valid for high frequency because it is approximate formula of ripple. Okay, approximate formula of ripple. Please mind it. To write down this formula of ripple, we assume that the current IL is almost linear. Is almost linear, but it is not necessary here. This current is linear. The nature of this current IL will actually decide by this system. And here, my dear friend, actually the response of IL will be exponential rising, exponential decaying. But due to high frequency, this time interval is very low. This time interval is very low. We can relate or replace this non-linear characteristics or nature into almost linear. Okay. So the main thing about this formula, IL is linear, and IL can be linear only when frequency is very high. So please mind it, beta. If frequency is not high, never take a risk in the GATE or ES subjective exam. Otherwise, sometimes you can lose your all marks of this question. Okay, total marks of this question. So please mind it, beta, if frequency is very low, always apply conventional approach to handle that type of question. But here it is objective question. So I'm going to handle this one. Okay. After finalizing whether this current IL is continuous or discontinuous. Okay, dear. Now, my dear friend, see, the turn on time is given 4 millisecond. So alpha is a turn on time. So alpha is beta T on by capital T. So 4 millisecond by 10 millisecond will be 0.4. So you can write somewhere here alpha is equal to 0.4. Just keep in mind. Now beta, for the time period of 0.4 T, this chopper is on, and for 0.6 T, this diode is on. Dear friend, please mind it. When this chopper is on, VL inductor will charge. So VL is nothing but 200 or Vs minus this VR. Okay. Now dear see beta. The V0 average according to this will come some value. And here the value of resistance is 4 ohm. So I am going to write in case first when chopper on in the range of 0.4 T to T, VL is equal to Vs minus VR, and case second beta 0.6 T to T, when diode is on, please mind it, chopper will be off and VL is equal to VR. So VL is equal to VR. Now you can satisfy volt second criteria, and if positive voltage of inductor is equal to negative voltage of inductor, our current will be continuous. Okay, and please mind it, this is not sufficient criteria. Also your VL should be continuous. Okay, when you will plot by this approach. By this thing we can say IL will be continuous. So it is bit lengthy process. That's why generally person avoid it. But my dear friend, in the power electronics syllabus, I'm going to start by 20 seconds as I told you. I will cover all these things in detail. Okay. Now see dear. If the current IL is continuous, then step down chopper V0 average will be alpha into Vs. So V0 average is 0.4 into Vs 200. So it will be how much? 200 into 0.4, 80 volt. Okay. Now dear, V naught average is 80, VL average is 0, you know, so VR average equal to V naught average. So what will be the IL average? Please mind it. VL average is 0, okay. So V naught average is equal to VR average. So by Ohm's law, VR average is equal to, we have calculated 80 IL average into R. So IL average, not IL beta, okay. Wait a minute. Yeah, IL average, or you can say I naught average. Both are same. IL average or I naught average is VR average by R. So 80 by how much? The value of R is 4. So 4 is how much? 20 ampere. Now tell me everyone, it is clear to all? So beta the I naught average is 20 ampere, and he is asking the average value of diode current. The average value of diode current. What will be the beta ji this conduction period of this diode? The conduction period of diode, as I told you here, 0.42 sorry, alpha is point, yeah, 0.42. So chopper is on, wait a minute, chopper is on 0 to 0.40, okay beta, and this diode is on 0.42 T. Okay, so what is the conduction period of diode? Diode conduction range is 0.42 T. Now beta, in this range, one current will flow through the diode in such fashion, and we have to calculate the value of this diode current. And this peak value will be IL average plus del IL by 2, and this value beta will be IL min, okay, IL min. Now beta, ripples are given, del IL is equal to, as I told you, 4 ampere, okay. So you can calculate IL max is equal to IL average plus del IL by 2, and IL min is equal to IL average minus IL del IL by 2, okay. So by this equation beta, you can calculate max and min and put here, so that you can easily calculate the average value of diode current, okay, by the area. So this is 0, 0.4, and finally it is T. Now tell me, it is clear to all? Now if you dear, if you have any doubt, you can ask to me. Now you can solve this question, okay. Please read this question carefully everyone and tell me the correct answer. I am giving to you 80, yes Abhishek, I am giving to you around 30 seconds. So read this question carefully. It is very easy example, my dear friend. Okay, I am waiting. Okay dear, now see. My dear friend, tell me again the name of this chopper. Okay. Already here written buck converter. Why it is buck? As I told you, inductor location is this one. Okay. So this is a step down chopper with low pass filter. Please mind it everyone beta. With low pass filter. This LC combination is called low pass filter. Now see something. The output voltage and the inductor current can be assumed to be ripple free, the most important thing. So this output voltage and this inductor current ripple free. So the inductor voltage beta VL is this one during a complete switching interval. What is the meaning of beta switching interval? 0. This is capital T. It is T on, already mentioned. Okay beta, point 3. Let's check it. This is beta T off. As I told you, when inductor current is continuous beta, doesn't matter, or discontinuous also, the average voltage of inductor will always be 0. Okay, so the positive area A1 should be equal to negative area. Dear C, we can write 30 into T on is our positive area is equal to 20 into T off. So 0, 0 cancel. What will be the T off beta? T off is 1.5 times T on. See whether it is right or not. Now dear, assuming all devices are ideal, the duty cycle of the converter. Dear friend, duty cycle is nothing but alpha T on by T. What is T on? So T on we can write simply T on beta, and T we can write T on plus T off. So T on plus T off is equal to 1.5 times of T on. So dear, here we can write alpha is equal to T on by T on plus T off is 1.5 T on. So it will be T on by 2.5 T on. So what will be its value? 2.5 inverse. Yeah. So the duty cycle beta G will be 0.4 is our final answer. Yeah, 0.4 is our final answer. Okay. So this is the thing dear. Please match Abhishek where you did a mistake. Now my dear friend, we are going to handle next example, and it is also very nice example. Just read this example carefully and tell me correct answer of this question. In the circuit shown in figure, all the elements are ideal and the switch S is operated at 10 kilohertz and duty ratio is 60%. So first most important thing beta for this, frequency is very nice. 10 kilohertz is moderate frequency, not very high, not very low. So you can assume your inductor current almost linear. Now 60%, so alpha is 0.6. Now beta, what will be the time period of switching? So T is equal to 10 by 1000. So simply we can write 10 millisecond. Okay. Not sorry. 10,000. So yeah, 100 microsecond. So this time will be 100. Okay, I'm removing this. So T is equal to 100 microsecond. Now dear, the capacitor is large enough so that ripple across it is negligible. My dear friend, that means this output voltage across this R will be ripple free. So V0 is ripple free. Okay, please mind it. Now beta, an steady state acquires a voltage as shown in figure. Yeah, voltage is not given. The peak current in ampere drawn from the 50 volt source. Here, the peak current we have to calculate. So, I peak. Now, let us see, this is the figure in which we have to calculate this I peak. But before that, somebody can tell me this IL is continuous or not. So see, capacitor is large enough something, steady state, switch opens, something. Yeah, nothing is given. So, but according to that criteria, volt second, this IL will come continuous only. This IL will come continuous only. Now dear, for the buck boost converter, what will be the ripple formula? Del IL Vs into alpha into T divided by L is the ripple formula for this. But what will be this I peak average? Or I peak max is nothing but this IP whatever max is nothing but IL average plus maybe any other current plus del IL by 2. Now dear, it is very easy to calculate ripple and IL average. Ripple and IL average. Please tell me everyone, it is clear to you? Okay. So rest like calculation part you can handle. And please dear student, all formula keep in your mind related to buck boost converter, step down and step up. So please solve this example. If you have any doubt, you can WhatsApp me or you can like ask your doubt by any approach by contact or WhatsApp. Now dear, we are going to discuss our example related to magnetic circuit. Related to magnetic circuit. Please read this question carefully and tell me the correct answer. Everyone dear. In the circuit shown in figure, it is found that the input AC voltage VI and the current I are in phase. Okay. The coupling coefficient K, you know formula, M by under root of L1 L2, where M is mutual inductance and the unit of mutual inductance is Henry. Between the two coils, the value of K and the dot polarity of the coil PQR. He is asking. The most important line beta in this example is it is found that the input AC voltage VI and the current I are in phase. Means beta this current I and this voltage V phasor diagram wise will be in the same phase. Let beta this is obviously supply. So what will be the supply power factor? Supply power factor is nothing but unity because V and I are in the same phase. So first line says that your supply power factor is 1. This is the most important thing. Now dear friend, you know very well, this system can provide unity power factor when we have only pure resistive load. Pure resistive load. It means dear, this coil combination should cancel by this capacitor. So if the value of XC, please mind it, if the value of XC is minus 12J, okay, minus 12J ohm, then the value of entire coil XL should be plus 12J ohm. Okay. Now dear, see, what is the method to identify equivalent inductance when we have two coils and in between these two coils mutual inductance is also present. Okay, see my dear friend, L equivalent of coil. First we have to add both. So how much it is? 8 and 8, 16J. Dear C, we require only 12J, but it is coming 16J. So we required here some less value. Okay, 12J. So here we required a negative sign. And how much? 4. How much? 4. It is beta minus 2 times into M. I think you have basic idea. So what will be the value of M? M should be equal to 2. So 2 into 2, 4. This one. Wait a minute, beta. If the current entering in this dot and he is asking like dot will occur either at point P or Q. Suppose beta, if dot occurs at point P, then this dot and that dot both are like current is entering in both dot in the same direction. Okay, so this dot that means dot at point P and this dot will introduce here positive sign, here positive sign. So for the negative sign we require dot at point Q. It is clear to all? At point Q. Dear friend, if one dot is entering, another dot is leaving, sign will be negative. And what should be the value of M? M should be equal to 2. Okay. So 2 into M, it means beta G, it will be 16J minus 2 into 2. So 4J is equal to 12J. And M is 2. So M must be equal to 2. What is asking? The value of K. So the K is under root M by under root L1 L2. So you can put K is equal to, wait a minute, M by root L1 L2. So what is the value of beta M? 2 divided by root L1 is 8 and L2 is also 8. So 8 and 8. How much it will be? 2 by 8 I think. So 2 by 8 is 1 by 4. So 0.25. Is there any choice or option? Yes, beta. So option C is right. Option C is right. Okay, dear. So now our next problem is this one. Please everyone read this problem carefully and tell me the correct answer. Okay, do one thing beta. Just take a screenshot of this problem and a screenshot of this problem and try to solve both problems in like your free time, because this type of problem will improve your concept. So for practice these are very important problems. Okay, for example dear, in this problem no difficulty is there. What will be the current I? This positive 200, negative 200, obviously this polarity will be negative only. So yeah, this is wrong. So positive negative, negative positive will cancel to each other. What will be the value of current I? Is nothing but how much? 5 ampere. 100 by 20. Okay. Because this thing and that thing will cancel to each other. So circuit will provide resonant condition. Circuit will provide resonant condition. It is clear to all? Okay, dear. So thank you everyone. Take just a screenshot of these problems and try to identify the solution. Okay. Thank you. If you have any doubt, you can text me or you can call me also. Okay, no issue. Thank you, dear.